All right, so now let's go to example 1. And here we are going to follow those 4 operations and we're going to find them. But the wonderful thing about this is that what we do for example 1, we're going to use those answers when it comes to example 2. All right, so we're given this function, the functions f of x equals 3x squared minus 4 and g of x equals 4x plus 5. And we're going to find each of the following functions here, each of the following operations. So starting off with addition, and if you notice there, I put both there. So we have f plus g of x, and then we have f of x plus g of x. Remember, they mean the exact same thing. So make sure you know that they are the same. There's no difference in them. All right, so here we're going to go and write it out. So we have let's do equal sign, sorry. We have 3x squared minus 4 plus 4x plus 5. And again, 4x plus 5 is g, and then the f of x is the 3x squared minus 4. Right? So now, at this point, we substitute it in. So we substitute the functions. And now we go ahead and combine like terms. That's our next step. Combine like terms. All right. So here, the only like terms that we have are -4 and +5. So only like terms. So here, we'll have 3x squared plus 4x plus 1. All right. And again, I'm going to write this right here. We have that. Now, with that again, we're going to use this for the next example. So keep that. Don't lose it. All right, so let's go to B. To be or not to be. Ha ha ha. Oh. All right. So again, we're going to write down, we're going to do subtraction. So f minus g of x is the same thing as saying f of x minus g of x. So let's go ahead and write this out again. And that was 4x plus 5. Okay, so we have those. And so now we go ahead and work it out. And again, we substitute it in. I'm going to just copy that down, what we did right here. Sorry about that. Moving things around. I just need to clone you. Come here, clone. Come here. Come here, clone. All right, so again, we just substitute the function. It should be functions. All right, so we substitute our functions in. All right, now we go ahead and distribute. Oh, why'd it jump? Sorry about that, guys. Oh, it jumped on me randomly. Okay, so I think we're good. All right, so we distribute the negative. So we're here distributing this negative through. All right, so on this line, we have 3x squared minus 4. And you can say minus 4x plus 5. Or I'm going to write this over here on this side too. You can write it this way. You can write it like that too if you want to. Blue one's the best way to do it. But if you want to write it that way in the black, that's fine too. No problems, no qualms. All right, so then again, we go ahead and combine like terms. Okay, so we combine like terms. Again, the only like terms that we have are the constants. Oh, sorry. Oh, I messed that up. Sorry, guys. Ooh. We distribute the negative, and I do the error that most people, not most, but a lot of people do. It should be minus 5. So negative times a positive is negative. So it's negative 5 there, and this should be minus 5 right here too. I apologize for that, guys. But it's okay. Everybody makes mistakes. Everybody has those days. So when we combine these two right here, we get negative 9. So we get 3x squared minus 4x minus 9. And that's when f of f minus g of x. That's what that equals. Okay, cool. We're not doing bad. We're good. We're good. All right, I'm going to move this down just a hair. Hopefully the whole thing will go. All right, so with it, we're moving now into our multiplication. Let me go move my division 1 down too. So we need some more space. There we go. All right, so we're going to do some multiplication now. So C is f times g of x, or same thing as saying f of x times g of x. Same difference, no changes. All right, so we're going to do this. And it's times. So again, we're filling in what we had, our functions. All right, so again, we're substituting functions in. All right, we're going to go ahead and do FOIL. First, outside, inside, last. All right, so when we do that, 3x squared times 4x. 3 times 4 is 12. X squared times x is x cubed. All right, we can also do 3x squared times 5. So 3 times 5 is 15. And then x squared times 1 is x squared. Right? So then we go to the next one, negative 4, which is your inside. So sorry. The green one was your the first in both. The black one was the outside numbers. The red one now is the inside numbers, the I. So negative 4 times 4x squared. 4x is negative 16x. And then our last part is negative 4 times 5. So negative 4 times 5 is negative 20. And that's it, guys. That's all we did. And for first off, we would say, okay, at this point, now we need to figure out, can we combine any like terms? There's no like terms to combine there because it's an x cubed term, an x squared term, an x term, and then a constant. So nothing else. Nothing else. All right, so we're good on that one. Look at God. My God. My God. All right, and then here's our last one. Go up just a little bit. All right, and again, the first step is to go ahead and substitute the functions in. Always that first step. I'm going to do it underneath here. So again, 3x squared minus 4 up top. On the bottom, we get that 4x plus 5. Okay, and again, we're just substituting in. Oh, never mind. I'll write that down here. We're substituting the functions again. That's all we're doing. All right, so now, after we substitute the functions, we try to see if there's any way we can simplify it down. If we factor numerators, there's something that can cancel out the denominator. You can factor numerator and denominator, like all that's great stuff. And if you look at it, we really can't factor out the numerator. We can't factor out the denominator. And there's nothing that can be canceled because there's nothing in common there. You can't say, well, there's a 4 here and a 4 here, so we can cancel out the 4s. Nope. Remember, 3x squared minus 4 is married. So if you're going to break that apart, you have to actually do like 2 separate households. So it's, in other words, 2 different parentheses or a number in a parenthesis or some of that sort. So with that, you cannot just break it apart like that, just randomly. All right, so here, since we can't break anything apart, now we move into figuring out what is our domain, what x cannot equal. So here, we're going to How did I say this before? All right, we're going to do it like this. So we said that g of x cannot equal 0. So to figure out, sorry, not g, but g of x. So to find out like what that is, we kind of have to set g of x equal to 0. And then we're going to solve for the variable. And then that's going to tell us what part of the domain we cannot have. In other words, what x cannot equal for this, because it'll make it an undefined function, which we cannot have. So what we're going to do, I'm going to do it over here on the left side here. We're going to do 4x plus 5 equals 0. We solve it out. We divide, so we subtracted 5 from both sides. Now we're dividing both sides by 4. And we get that. And so here, what we're going to say is, okay, what makes the g of x function equal to 0 is if you put negative 5/4 into the problem. And so here, okay, we're not trying to do that. We're not trying to get 0 for denominator. So we say x cannot equal negative 5/4. And so therefore, that's the portion that we were talking about right here. All right, and that's it. That's all you have to do for the function. If you can't simplify it down, you must find that portion where x cannot equal the part of the domain that does not work for the problem, and then we're done. All right, so that's example 1, guys. So all these we're going to use again in example 2.